welcome to the final session. So, in the previous sessions we discussed the necessary theory part of dynamics of rigid bodies. Also we discussed the theory to determine the moment of inertia of a flywheel, and the last session we demonstrated virtually the experiment to determine the moment of inertia of a flywheel using Amrita Virtual Lab facility. So, in this session we are just discussing some numerical problems. So, nowadays the students are facing problems to solve numerical problems in physics. However, if you are able to understand the concepts which is there in the question, and if you know the formula, it is very easy for you to tackle those problems. So, very importantly, you have to learn and by heart each formula that we discussed in this session, so that it will be easy for you to do the numerical problems. All the problems are you can solve the problems very easily. So, just concentrate on the concept, then apply the necessary formula. So, this is the first problem. You can see a uniform circular disc of mass 1 kilogram and radius 5 centimeter rotates about an axis passing through its center and perpendicular to its plane. Calculate its moment of inertia. So, just read the question in a relaxed mode, and first importantly you please write the data which is available in the question. Okay. First you have to imagine there is a uniform circular disc. We have a uniform circular disc. Yeah, circular disc is here. Its mass is 1 kilogram. So, just write the data m equal to 1 kg, and please note that whether the units are in SI or not. If it is in CGS, just convert those units in SI. So, m equal to 1 kg, radius of the disc it is equal to 5 centimeter. So, you have to convert to meter. So, these are the first preliminary steps after reading a question. Just write down those variables. So, r equal to 5 into centimeter to meter, 10 raised to minus 2 meter. Now, understand the direction of the axis. About an axis passing through its center and perpendicular to its plane, right. So, passing through its center and perpendicular to its plane. So, you know what is the expression of moment of inertia of a disc about an axis passing through its center and perpendicular to its plane. Just write here I equal to m r square by 2. That is it. So, just apply the formula, then substitute the values of the variable. Okay. Do not get panic after seeing a numerical problem. All problems are you can solve all problems in very easily manner. So, just substitute m equal to 1 into 5 square into 10 raised to minus 2 square, it is 10 raised to minus 4 divided by 2. So, it is 25 by 2 into 10 raised to minus 4. Okay. So, just see 25 by 2 into 10 raised to minus 4. So, it is 12.5 into 10 raised to minus 4 kilogram meter square. Okay. So, this is the moment of inertia of a of a circular disc about an axis passing through its center and perpendicular to its plane. Hope you understood this numerical problem. We can go to the next problem. Show that the moment of inertia of a circular disc of radius small r and mass small m about a tangent line in the plane of the disc is 5 by 4 m r square. So, you have to prove that the moment of inertia of a circular disc of radius r and mass m about a tangent line. Okay. So, you have the disk here, you need to find out the moment of inertia of a circular disk of radius small r. So, radius equal to small r and mass equal to m about a tangent line. So, this is a tangent line, right. Tangent line is 5 by 4 m r square. It is very simple, right. You know the moment of inertia of the disk about its diameter. Moment of inertia of the disk about the diameter, it is m r square by 4. So, we have to find out the moment of inertia of the disk about the tangent line, which is I, which is equal to moment of inertia of the disk about the diameter, which is m r square by 4 plus what, m into separation between the axis, square of the separation between the axis, m r square. So, it is m r square by 4 plus m r square, which is nothing but 5 by 4 m r square. So, in this way you can prove the moment of inertia of a circular disk about the tangent line is 5 by 4 m r square. So, just understand the concept and apply those formula, that is it. So, the problems are very easy in the dynamical part, sorry, in the dynamic topic. So, just understand the concept and you have to know what are the formulae we need to apply. Hope you understood this one also. We can go to next one. So, here calculate the moment of inertia of a solid cylinder of mass 5 kg and radius 0.5 meter and length 4 meter about an axis passing through its geometrical center and perpendicular to its length. It is a direct question, direct substitution. Calculate the moment of inertia of a solid cylinder of mass 5 kg. So, we understood that the shape is cylinder. So, the variables m equal to 5 kg, radius 0.5 meter, length 4 meter about an axis passing through its center and perpendicular to its length. What is the expression for the moment of inertia? I equal to m into L square by 12 plus r square by 4, that is it, m into L square by 12 plus r square by 4. Just substitute, all the variables are in SI unit. So, just substitute and get the final answer. So, it is up to you, just find out what is the final answer. I equal to m into L square by 12 plus r square by 4, direct substitution. So, the answer will be 6.9 kilogram meter square. 6.9 kilogram meter square. Okay. This is a direct question. So, do it yourself. We can go to the next problem. So, this is somewhat tricky. A uniform thin bar of mass 3 kg and length 0.9 meter is bent to make an equilateral triangle. So, we have a uniform bar of mass 3 kg and length 0.9 meter is bent to make an equilateral triangle. Calculate its moment of inertia about an axis passing through the center of mass and perpendicular to the plane of the triangle. So, here we need to draw that figure first. We have a uniform bar of 3 kg and length 0.9 meter is bent to make a equilateral triangle. So, the total mass 3 kg and length 0.9 meter is bent to make an equilateral triangle. You know the angle, it is 60, 60, 60 degree and each side will be 0.3 meter, right, 0.3 meter, 0.3 meter, 0.3 meter. So, these are 3 rows, right, of length 0.3 meter and mass 1 kg, 1 kg, 1 kg, 1 kg. So, total 3 kilogram mass is meant to make an equilateral triangle. So, each side 0.3 meter and 1 kg. And we need to find out the moment of inertia about an axis passing through its center of mass and perpendicular to the plane of the triangle. So, in this manner, passing through its center of mass and perpendicular to the plane of the triangle. So, first thing we are just giving P, Q, R. P, Q, R. So, this is the point of intersection. First, we are just going to find out the moment of inertia about PQ, moment of inertia of the side PQ about the perpendicular axis through O. So, this is the center of mass, perpendicular axis through O. So, we need to find out the moment of inertia about an axis passing through the center of mass and perpendicular. We are just finding out what is the moment of inertia of PQ, of the side PQ about that perpendicular axis. So, what is the formula? Moment of inertia of the side PQ about the perpendicular axis which is passing through this one. Here we can see C. So, moment of inertia of the side PQ or the rod PQ about an axis passing through this one, passing through C, which is passing through the midpoint of the rod and perpendicular to its length. What is the expression? It is m L square by 12. So, we are just going to find out the moment of inertia of PQ about an axis passing through C, which is given by m L square by 12, which is the moment of inertia of the side PQ about an axis passing through C. So, just substitute what is m? M equal to 1, what is L? It is 0.3 square divided by 12. 1 into 0.3 square by 12, it is 0.0075 kilogram meter square. If you know this moment of inertia of side PQ about the axis which is passing through what? Which is passing through C, 0.0075 kilogram meter per square. Now, we have to find out the moment of inertia about the axis which is passing through O. For that, we need to know what is the distance OC. If you want to find out the moment of inertia of the system about that axis, we need to know what is the distance OC. The distance OC is, this is 60 degree and this one, since it is an equilateral triangle, it bisects the angle. So, this one is 30 degree, this one is 30 degree. So, we need to know what is CO. So, it is opposite side by adjacent side. So, tan 30 equal to CO by PC, tan 30 equal to CO by PC, or CO equal to what? PC tan 30. CO equal to PC tan 30. So, it is 0.3 meter full length. So, bisect 0.15 meter, and what about tan theta? Just substitute. So, it is 0.15 tan 30. This 0.15 into tan 30, it is 0.086 meter. So, we got the length CO. So, we calculated the moment of inertia of the side PQ about C, and also we calculated the distance CO. Now, we can use the parallel axis theorem. Okay. Now, we are just going to use the parallel axis theorem, which is the moment of inertia of PQ about O, moment of inertia of PQ about an axis which pass through O, which is given by I equal to the moment of inertia of the same thing PQ about an axis passing through a center of mass. It is 0.0075 plus 0.0075 plus mass into, it is 1 into distance square 0.086 square. So, that you will get, it is approximately 0.015 kilogram meter square. Okay, 0.015 kilogram meter square. So, this is the moment of inertia of one side about the axis O. So, that is why I told you this is a tricky question. We need to find out the moment of inertia of this triangle about an axis O. We now calculated what is the moment of inertia of the side, one of the sides about O. So, if you want to get the moment of inertia of the whole triangle about O, you have to multiply this one with 3. So, moment of inertia of the whole triangle about O equal to 3 into 0.015 kilogram meter per square, which is given by 0.045 kilogram meter square. So, this is the answer. So, in this way you can find out the moment of inertia of the triangle about an axis passing through O. Hope you understood this problem. So, just do it very carefully. So, next, what must be the relation between the length L and radius r of the cylinder if the moment of inertia of the cylinder about its axis to be the same as the moment of inertia about the equatorial axis? It is very simple. So, they need what is the relation between length L and radius. If the moment of inertia of the cylinder about its axis, what is the moment of inertia of the cylinder about its axis? It is m r square by 2, right. It is m r square by 2, because r is the radius of the cylinder. It is m r square by 2. It must be equal to moment of inertia of the cylinder about its equatorial axis, which is nothing but the axis which is passing through its geometrical center and perpendicular to its length, which is equal to m into L square by 12 plus r square by 4. Just solve this one, just cancel m, so that you will get r square by 2, which is equal to L square by 12 plus r square by 4. We need to find out the relation between length L and radius r. So, solving this one, just take r square by 4 to this side, so that in the LHS it becomes r square by 4 equal to L square by 12, or finally you can write L square equal to 3 r square, L square equal to 3 r square, or what is L? L equal to root 3 r. So, this is the relation between L and r if the moment of inertia of the cylinder about its axis and about its equatorial axis should be the same. Okay. So, we can move to the next question. This one also a very important one. We have 4 spheres of each mass m and radius a are so placed that the centers of the spheres are located at the centers of a square of side B. Calculate the moment of inertia of the whole system about one side taken as the axis. Okay. Just imagine that figure. We have a square, okay. We have a square of side B. So, B is the side length. So, we are placing 4 spheres at each corner, okay, A, B, C, D, A, B, C, D. The spheres are having mass m and radius a. So, mass m and radius a. So, we need to find out the moment of inertia of the whole system. We need to find out the moment of inertia of the whole system about one side taken as the axis. If I am considering AB, you can consider AB or BC or CD or AD. So, you have to find out the moment of inertia of the whole system. So, first we will find out the moment of inertia of sphere C or D. First we will find out the moment of inertia of the sphere C or D. So, it is of mass m and radius r, and about an axis passing through its diameter, it is nothing but 2 by 5 m r square. It is 2 by 5 m r square, which is the moment of inertia of the spheres C or of the sphere C or D. Then we are now finding out the moment of inertia of the whole system, what about PQ. This is AB and this is PQ axis, which passes through this side. So, we are just finding out the moment of inertia of the whole system about PQ. Now, we got the moment of inertia of C and D about an axis which passes through C and D. Now, we need to find out the moment of inertia of this C or D about the axis PQ. So, you can use the parallel axis theorem about PQ, it is 2 by 5 mr square. So, now we are just finding out moment of inertia of C or D about PQ, it is 2 by 5 mr square plus 2 by 5 mr square, which is r is equal to a. So, the answer is 2 by 5 m a square. So, 2 by 5 m a square plus m into b square, So, that you will get the moment of inertia of the C or D about PQ, 2 by 5 m a square plus m b square. Now, you can find the moment of inertia of the C and D, either C or D, it is 2 by 5 m a square plus m b square. So, the moment of inertia of both C and D about this side PQ is twice this one, twice 2 by 5 m a square plus m b square. So, we now find out the moment of inertia of C and D about PQ. Similarly, we are just going to find out the moment of inertia of A and B about PQ. So, it is nothing but what? Moment of inertia about the diameter. So, moment of inertia. So, finally, we can write moment of inertia of A and B about PQ. About PQ is twice 2 into 2 by 5 m a square, 2 into 2 by 5 m a square. So, what is the final answer? What is the moment of inertia of the whole system about the side PQ? Just add these two. So, that you will get the final answer as 2 into this one 2 by 5 m a square plus m b square plus 2 by 5 m a square. So, this is the final answer of this question which is the moment of inertia of the whole system about this side PQ. First, you have to find out moment of inertia of either C or D about PQ, then moment of inertia of C and D about PQ, then find moment of inertia of A and B about PQ, just add these. Okay. With this, I am concluding this problem session also, just learn the formula thoroughly and just complete. So, thank you. So, we are now completing the entire portion of dynamics of rigid body. Thank you very much. Bye. See you.